In this lecture, I will discuss how to design shear wall in ETABS. Shear wall or lift well in ETABS. Okay, so in ETABS, shear wall can be designed in three ways. First one is the CNT method. Second one is the uniform reinforcing method. Third one is the general reinforcing method. So here I have defined previously shear wall. Okay. Here I am right clicking, wall is 200 millimeter, and what the properties I have defined in it. Go to define, section properties, wall sections. Okay, wall 200 millimeter, modify. Here the wall material property is FC prime to 28 megapascal. Okay, and modeling type shell thin. Here the modifiers I have applied 0.7. You can apply in the bending only 0.7. Bending M2 to 0.7, M1 to 0.7 as per ACI. Okay. So further I have assigned the peer labels. For example, first I go in the define peer labels. Here I have defined different peer labels. These are just names. Okay. For example, here I am defining P15, add new peer label. Okay. These are the labels. Then I have selected the walls and assigned the peer labels. Here I have selected the right click. Here I have previously defined the P1. For example, if I will select all stories, I select only one shear wall. All walls in the vertical will be selected. Okay. Go to assign, shell, peer labels. Here you can assign peer label P15. I have already assigned P1. Okay, apply. Okay, P1 to this, P3. So what about the peer labels? What are peer labels? For example, you can study peer label. Okay, here is a CSI America official website where you can study about the peer labels and spandrel labels. First of all, for example, P1, each story peer label is basically relevant to its story. For example, here S1, S2 are related to roof. Okay. Similarly, here P1, P3, P5 all related to this story. If it is exist in the other story, but doesn't matter. So here are the wording. Okay, let's see. Okay, here is the wording. Wall pairs are always associated with the story level directly above them. Okay, so all the pair labels are related to this story, and these all the pair labels related to this story. And for example, here P1, this all the elements are P1. Then this wall width will be from left to right, and this P3 is different pair label, so its wall length will be from left to right, from here to here, from this opening to this opening. Similarly, P5 from this opening to this end, this is are the wall widths. Okay, software will take the wall widths as per peer labels. Okay, so you can also study the wall spandrel labeling. Spandrel labeling are just the coupling beam. For example, this wall and this wall are connecting through a short element, that is a even this is a wall element, but this is a acting as a beam element to transfer forces from one wall to another wall. This connecting element is a coupling beam or a spandrel label. Okay, so we will assign also this. So here is the official website of CSI, means Computer and Structure Incorporation. Okay, so now I will come here. Okay, so by default the software design the shear wall by uniform reinforcing method. For example, I am right click on any wall and go to design. Here in the shear wall design, okay, view / revise peer overrides. Okay, here is the by default peer section type. Okay, software will design by default by uniform reinforcing method. Okay, so how many methods are there? Here design, shear wall design. Here three methods are there: simplified CNT method, uniform reinforcing method, and general reinforcing method. First of all, I will use the CNT method. For that, I will select all the shear walls, concrete walls. Okay, all the walls in the structure, and go to design, shear wall design, and assign pier section to simplified CNT design. Okay, so escape. Now I will go back and see shear wall design. Right click, click on any wall and go to design, shear wall design, view / revise, pier overrides. Here you will see now the pier section type is changed, simplified T and C. Okay, so first of all I will run analysis and then go to design. Then design will be done with the method of simplified CNT method. Okay, analysis is complete. Now I will go in the design, shear wall design, start design / check. Okay, now software has completed the design by CNT method. Here I am right clicking on any wall. Okay, software will display the design report. Okay, for example, here second wall, let me zoom. Okay, here is the properties, which story, what pier ID, okay, and what strength of steel, okay, concrete FC prime 28 megapascal, okay, and here is a flexure design, tension reinforcement, because this is a CNT method, tension and compression method, tension reinforcement and compression reinforcement. Okay, here is the rebar, okay, in millimeters here, and here is the shear design. Okay, at top and bottom the shear reinforcement is a 500 millimeter square per meter. Okay, and second, that is a boundary element check, either boundary element is needed or not. Here, not needed, not required, not required. Okay, when boundary element is needed, when the stress of compressive stress at extreme fibers increases. Here is the stress limit 5.6. So how 5.6? For example, that is a 0.2 of compressive and 0.2 multiply 28. Okay, that is the 5.6 megapascal. From where software is speaking, here is a book, Structural Concrete Theory and Design by Nadeem. Okay, shear wall can be designed by two methods for boundary elements, especially shear based design and displacement based design. Okay, here shear based design, software is saying if a special boundary element should be provided where the maximum extreme fiber compressive stress due to factor forces including earthquake forces exceeds 0.2 FC prime. Here in this case, in this wall, the compressive stress is less than 5.6, so no boundary element is needed. And further governing combinations are these. Okay, so that's how we design the shear wall by CNT approach. Okay, now I will design the same concrete wall with the uniform reinforcing method. What's the difference? In uniform reinforcing method, you can also check by giving the reinforcement, just like in columns. Okay, let's see. Okay, I will select again all the walls. Okay, now go to design, shear wall design, assign pier section. Now I am going to select the second method. Here, when I am selecting, software is asking please provide the data, bar size, bar spacing, clear spacing, okay, and corner bar sizes. Either I want to be checked or to be designed. This option is present in the uniform reinforcing method, not in the CNT method. Okay, so here reinforcement to be designed. Okay, so software will calculate the required reinforcement depending upon loading. Okay, or if you want to check, you can provide the number of bars and then check either your provided reinforcement is okay or not. So now I am selecting reinforcement to be designed because software will calculate the required reinforcement as per loading. Okay, so now again I will just click on any wall and go to design, check that whether the second method is selected or not, view/revise. So here pier section type now is the uniform reinforcing method. Okay, now again I will run analysis. Okay, analysis is complete. Now in the design, shear wall design, start design/check. Now software is showing the overall longitudinal reinforcement here, pier longitudinal reinforcement. Okay, so here basically I have assigned to this whole wall separate pier label and the second wall separate pier label. If I assign the same pier label to this wall and this wall, then the software will show the combined reinforcement for both walls. Please remember, if you assign separate pier labels to the separate wall, then software will give you separate reinforcement. And if you give the same walls same pier label, for example P2, and to the second wall also P2, then the software will give you combined reinforcement for the whole wall. Okay, so here the pier longitudinal reinforcement, again right click on any wall, right click. Okay, so here again you can see the summary. Okay, station location, software design at two locations, top and bottom of wall. Okay, required reinforcement at top and required reinforcement at bottom. Okay, and here is a reinforcement ratio, that is a raw value. Okay, that is a flexure design. Okay, top and bottom. Here is a shear design, shear reinforcement, and here you can see the again stress check. Okay, but software is saying the limit of 5.52 is okay, but there is basically two methods. One is shear based design and other is displacement based method. If the C value is greater or equal to this value, then again a boundary element is needed. So on that condition, software is providing the boundary element. Okay, so in which wall the boundary element is needed. So we can see here display design info. Okay, pier longitudinal reinforcement apply, that is already appearing. Okay, so let's see, pier reinforcement ratio apply 0.0025, pier demand over capacity ratio apply, that is also okay. Pier shear reinforcement apply. Okay, so what is the shear reinforcement? Then the what pier edge and boundary element widths. Okay, at not required, but at the bottom boundary element is required. Okay, boundary element in the form of columns means at the edges you have to provide the columns. Okay, so our already present columns, that will behave like a boundary element. Okay, now okay, so you can also see the rest of information also. For example, spandrel longitudinal, spandrel shear reinforcement. Spandrel is basically present at this lift well. Okay, first of all let me select all the walls. Okay, now show selected object only. Ready, let me zoom. Here is a spandrel element. So let's see the reinforcement in the spandrel element. Why this is spandrel element? Because when the force transfer from this wall to this wall, then the force will be transferred from this short depth wall. Okay, so how the reinforcement will be provided in this panel? I will go in the design, shear wall design, display design info. Okay, here I will select spandrel longitudinal reinforcement, apply. That will act as a beam. Okay, top reinforcement and bottom reinforcement. Similarly, shear reinforcement, apply. Okay, here right click, you will get all the information of spandrel design. Okay, here is a spandrel flexure design, top reinforcement, bottom reinforcement, and here is a shear design reinforcement. Okay, so how you will provide the spandrel reinforcement? First of all, the longitudinal reinforcement of the wall. For example, longitudinal reinforcement of the wall. For example, here in this wall 1100. Let's see what's okay. Here required reinforcement is 1100. So here, for example, if you pick this 16 millimeter dia bar, whose area is 199 millimeter square. So here the required area is 1100 and the total length of the wall is 2200. Okay, so here I have selected 1100. Okay, so then divided by one area of one bar. Okay, so let's see from the default. Okay, so here the dias are in the inch, so but our values are in the millimeter square, so we can pick the values. For example, here is 0.31 inch square for the number 5 bar. For example, for the 4 bar, that is 0.2. In the millimeter, that will be 144 millimeter. In different countries, manufacturer make different dias. So in our, that is number 4 bar is 144 millimeter square. Okay, so total required is 1100 divided by 1 bar area. That means 7.63 bars are required, or round up means 8 bars will be required. Okay, so then you will divide the full length. Full length is of the wall is 2200 divided by 8. Okay, that is 275 millimeter. Okay, if you this spacing will be for the longitudinal reinforcement if you provide one curtain of reinforcement. Okay, one curtain means here is the reinforcement on the one side and on the other side. One side, one curtain of reinforcement, second curtain of reinforcement. If you provide two curtain of reinforcement, then you have to divide the spacing on each side. For example, 4 bars on one side and 4 bar on the other side. So now I will divide 2200 divided by 4. So 550 spacing will be provided on the one side and other side. Now you have to check the criteria, minimum and maximum spacing criteria of the bars. So here, minimum and maximum spacing criteria of bars. Okay, you can also study. Okay, so that's how you will provide the longitudinal bars. And for the spandrel bars, okay, there is a criteria. Spandrel or for coupling beams, if your length of the beam of the wall is divided by h is greater or equal to 4, okay, then the design couple should satisfy the requirement of luxurious special frame ACI section 18.10 this. Okay, if your length over height is less than by 2, then there should be a diagonally spaced reinforcement should be provided. What is this condition is saying? Okay, here if your values ln by h is less than by 2, so this type of diagonal reinforcement, otherwise you will provide the horizontal and vertical reinforcement. Okay, so that is the second method of designing the shear wall. Now close. Now the third method. If you, for example, if you need to provide the boundary elements, you do not need to go to define section designer and make a new section with boundary elements. Software make automatically show all objects. Okay. Now, for example, here this is the wall. I want to make the columns to be boundary elements, act as the boundary elements. Here I will select all the columns. For example, let me see what's the pier level of this P1. Okay, so I will select all the columns to the side of the wall. Okay, 5 members on the left, 5 members on the right are selected. Now I will go to the assign, frame, pier label. Okay, the pier label is P1, apply. Okay, so its columns pier label is also P1 and this wall pier label is also P1. Okay, now I will select this wall. Okay, and go to design, shear wall design. Okay, assign general reinforce. Okay, general reinforcement. Okay, here the software is pier 1 that is already defined. I will go how you will define the pier. Shear wall design, define general pier section. Here is predefined. I will delete that and create a new pier section. Okay, whose pier name is, maybe you can say pier wall. Okay, whose base material strength is this, starting from existing wall pier. Starting from existing wall pier, okay, whose label is P1. Okay, so you can select any story starting from existing wall pier. So let's start from wall 1. So here you can see the section design. Okay, software here automatically pick the end columns as a in this section designer. Okay, that is the benefit of general reinforcing method. Okay, okay, okay. Now I will go into design, shear wall design, assign pier section to general reinforcing. Okay, here is the pier wall, section at the bottom, section at the top. Okay, reinforcement to be checked. You can change the reinforcement in the section designer. Okay, here I want to check the I want to reinforcement to be designed. Okay, so now I will press escape. Okay, and just click the wall and design, shear wall design, check view / revise pier overrides. Now you can see here pier reinforcement. A general reinforcing method has been selected, section bottom, section top. Now I will run analysis and design. Okay, again you can see all the information. Okay, now you can see not required. Okay, again you can see all the information. Okay, for shear wall design, display design info, okay, pier longitudinal, all the reinforcement, and then you can make the drawing of this. Okay, there is one beautiful function. Software can also generate the detailing drawing of shear wall. Here, start detailing. Inner core wall. Okay, so you can edit these drawings also. So that's how you can design the shear wall in ETABS.